to calculate the shear force and bending moment diagram, and also we have uploaded one video on the first case, that is simply supported beam carrying centrally point load. So whatever content you are seeing over here, already we have uploaded the videos on all these content, basic contents. Okay, and we have covered this first case, that is simply supported beam carrying centrally point load. So now the next second case, simply supported beam carrying eccentric point load. So why we are calculating, or why we are considering this point load as eccentric point load? Because if we see in the previous numerical, we have considered the same distance of that point load from A point and B point, that was L by 2 and L by 2. But now here we are considering that distance is different from the A point and B point, means the distance of that point load is different from A point and B point. So from A point we are considering small a distance, and from B point or the B support we are considering small b as a distance of that point load. So as we know, once you get the diagram, so first we have to draw the free body diagram, or we can say the line diagram. So while drawing the line diagram, first draw the support reactions as per the support given to us. Now here we have roller support at A point and the roller support at B point. So we know the roller support having one support reaction, and which is always perpendicular to the roller. That's why we are considering RA support reaction at A point vertically, and the RB support reaction at B point, which is also vertical. Why? Because plane of roller is horizontal, and that support reaction will act perpendicular to the plane of roller, that is vertical. So again, we know that while calculating the shear force and bending moment diagram, our first step is calculate the support reaction, second step calculate the shear forces at each point, and the third step is calculate the moment at each point. So while calculating the support reactions, we have three equilibrium conditions, and out of that three equilibrium conditions, we are using first equilibrium condition, that is summation MA is equals to 0, where summation MA is equals to 0 means what? Movement at A point, or algebraic sum of movement at A point. Okay, so if you see over here, we have considered support reaction at A point, that is RA, and the support reaction at B point, that is RB. Okay, so we are taking moment at A point, that is summation MA means movement at A point. So we have three forces, RA, RB, and 1 W kilonewton. So if we take the moment of that RA, so the moment of RA is 0. Why? Because the RA is exactly passing from the A point, and the formula for the moment is force into perpendicular distance. And if RA is passing from A point, then perpendicular distance of that RA from A point is 0. So no need to take the moment of RA at E point, because of perpendicular distance is 0. Okay, now take the moment of that W and then moment of RA, and we know while applying equilibrium conditions we can use any sign conventions, means clockwise positive, anti-clockwise negative. Now here where we will consider clockwise movement as a positive movement. So this W kilonewton force will produce the clockwise movement. That's why we will consider the movement of that W is positive. Okay, and the formula for movement is what? Force into perpendicular distance, and the distance of that W from capital A or from A support is a small a, the moment. That's why the moment is W into A. Then second moment of RB, then that movement is produced anti-clockwise, so we will consider anti-clockwise movement as a negative, and the perpendicular distance is L. So the moment of RB is minus RB into L. So we have this equation. Just solve these equations to calculate the RB. How we can solve it? Just take that RB on right side. So it will be WA is equals to RB into L. Okay, and now then take that L on left side. So it will be WA by L. So the reaction at B point is WA by L kilonewton. Why kilonewton? Because our force is in kilonewton. Now here we have calculated the support reaction at B point. Next one, calculate the support reaction at A point. So for the calculation of support reaction at A point, we have another equilibrium condition, that is summation Fy is equals to 0. Okay. So in Fy means algebraic sum of all vertical forces. So here we have three vertical forces, that is Ra, Rb and W, where Ra is upward, W is also Ra is upward, Rb is upward and W is downward. So for applying summation Fy equals to 0, we will use upward force as a positive force and downward force negative. So Ra and Rb both forces are upward, so we will take that Ra and Rb positive and W is downward, so it is negative. So equation will be Ra plus Rb minus W is equals to 0. The value of Rb already we have calculated, that is Wa by L. So just put the value of Rb. So Ra plus Wa by L minus W is equals to 0. And here we require Ra, so just take that Wa by L minus W on right side. So it will be Ra is equals to that W is minus, so take it positive, and so Wa by L is positive on left side, so on right side it will be negative. So just take the cross multiplications. Okay, over here, so W into L minus Wa divided by W. So just put L is equals to A plus B to calculate exact value of Ra. So if we put value of L, that is W into A plus B, where L is what, or A plus B is what, L. So just solve this equation, W into A plus W into B minus WA divided by L. So here we can see WA plus WA and minus WA will get cancelled. Remaining term is WB by L. So support reaction at A point is WB by L kilonewton. So now here we have calculated the both support reactions. The support reaction at A point, that is WB by L, and the support reaction at B point, that is WA by L. So once you calculate the support reaction, the next step is what? To calculate the shear forces at each point. And for the calculation of shear force at each point, we know that we have to take the section at left and then right of that particular point. So here we have 3 points, that is A, C and B. It means we need to take the section at A left, A right, then section of C left, C right, and then section of B left, B right. Okay, so just start with the calculation. So, and the second important thing is what? While calculating the shear forces at each point, we need to focus rules for the sign. So we need to follow the shear force calculations rules as we have discussed in previous video. So what are that rule? Just take the couple, okay, and take the section between that couple. So that rules says that if any force on left of that particular section and the direction of that force is upward, so we need to take that force as a positive and downward force as a negative. Similarly, if any force on right of that section and the direction of that force is downward, so it should be positive, and upward force is negative. That is the simple sign conventions that we need to consider while calculating shear forces at each point. So as we discussed, just take the section at A left and then focus on left of that section. Why on left of that section? Because we have started our calculation from left to right. Because if simply supported beam is given, so we have the both support reaction Ra as well as Rb. So we can start our calculation from left to right or right to left. But it is as per my suggestions, for simply supported beam, always start your calculation from left to right. Okay, just do that practice, so you will not get confused. So from which point we need to start for the calculation. So for simply supported beam, always start your calculation from left to right. So here we have started our calculation from left to right. That's why we need to focus on left of that particular section. So here section at here section at C left. That's why we are calculating the shear force at A left. Here, that's why here we have considered the section on A left. So the shear force A left, SF means shear force, A means A point, and L means left. Okay, so here it means we have considered the section on A left. So if we focus on the A left, there is no any force. That's why the shear force at A left is 0. Now second thing, after that consider the section on left right. After that consider the section on right of A point, and then focus on left of that particular section. And if you see on the left, only one force is there, that is RA, and the direction of that RA is upward. That's why consider positive. So what is the shear force at A right? So shear force at A right is RA, and RA support reaction is WB by L. So WB by L. After that consider section at C left. Okay, so C left, then focus on left of that particular section, because we have started our calculation from left to right. Again one force is there, that is RA, and the direction of that RA is upward, so it is again positive. So shear force C left is again RA, that is WB by L. After that consider the section on right of that C point, and then focus on left part. Now here we can see two forces are there, that is RA and W, where RA is upward, so it is positive, and the W is downward, it is negative. So the shear force C right is what? It is shear force C right, RA positive, W negative. So RA minus W, where RA is WB by L minus W. So just take the cross multiplications, how they have calculated WA by L over here. So WB by L minus W. So just take the cross multiplication. So it is WB by L minus WL. So just put L is equals to A plus B. So that is WB minus W A plus B whole divided by L. Okay, just solve this bracket. So it will be WB minus W into A, that is minus WA, minus W into B, that is minus WB, whole divided by L. So plus WB and minus WB will get cancelled. Remaining term is W minus WA by L. So this is minus WA by L. So now here we have calculated the shear force at C right. The next term is what? Just consider the section at B left, and then again focus on left of that particular section. Okay, so what will be there? Okay, if you see on the left part, again two forces are there, that is RA and W, where RA is upward positive and W is downward negative. So here shear force B left should be there. Shear force B left, RA minus W. So this equation is same. Here we can see. Okay, so the final value is also same, that is minus WA by L. Now after that consider section on B right, and then focus on left. So if you focus on left of that particular section, now here we have three forces, RA, RB and W, where RA and RB upward. So as per the sign conventions, we will consider RA and RB positive and the W is negative. So the equation at B right is here B right, BR. So the equation at B right is RA positive minus W because of downward plus RB. Okay, so RA is WB by L. So minus W, keep it as it is, and the RB is WA by L. So for solving this equation, we will get the shear force B right is 0. How? That is WB by L. Just take the cross multiplication. That is WB by WB as it is, W into L, then plus WA whole divided by L. Again put L is equals to A plus B. Okay, solve this equation. So that will be WB minus W into A, that is WA, then minus W into B, that is minus WB, and then WA as it is. So whole divided by L. So WB get cancel, WA get cancel because of plus minus. So remaining term is 0. So shear force shear force B right is 0. Now, once we calculate the shear forces at each point, the next step is what? Draw the shear force diagram. So if you see, while drawing the shear force diagram, first we need to consider the baseline. And if the shear force value is positive, so that value should be considered upward, and the shear force value is negative, so it should be in downward. So here we can see the shear force A left means A left point at A point on left it is 0, so it will start from this point. And if you see on A right, so exactly at A right the value is plus WB by L, so it is positive. Okay, so WB by L, so it is positive, that is WB by L. And if you see the shear force C left, it is again WB by L, means the magnitude at A right and B left is same. It means the shear force diagram from A right to B left is constant, and the values are WB by L. Now after that, if you see the shear force at A right, so A right is minus WA by L, so it means it should be at below to the baseline. So it is at below to the baseline, and from C right to B left, the value is constant, means shear force is constant from this point to this point. Okay, means C right to B left is constant, and the magnitude is WA by L. So this is our shear force diagram. Once you draw the shear force, the next step is what? To find the bending moment at each point. And to find the bending moment at each point, we need to consider the section at each point, means section at A point, section at C point, and section at B point. Okay, directly. And while calculating the bending moment at each point, we need to consider the actual sign conventions. Okay, sagging bending moment positive and the hogging negative. So how we can consider the sagging? Means just consider the one beam, the point load is towards the downward, so that beam will bend like this. It means movement at left point is clockwise and movement at right point is anti-clockwise. So this is our sagging bending moment concept. Already we have discussed in last video. Okay, so while calculating the bending moment, just take the section between that both movements. So it will give us if any bending moment or any clockwise bending moment on left of section, it should be positive, and any bending moment anti-clockwise on right of that particular section, it is also positive. So here we have started our calculation from left to right, so we will focus only on the left sign convention. So on the left, clockwise movement is positive, so obviously anti-clockwise movement will be negative. So just start with the bending moment calculation. So movement at A point means take the section at A point and then focus on left of that A point. There is no any force, so movement at A is 0. Then next point that we have C. Again take section at C point and then focus on left. So on left we have one force, that is RA, and the movement due to that RA is clockwise. So it just rotate your A or RA about the C point, that is clockwise, and the magnitude of that movement is RA into perpendicular distance, and the perpendicular distance is A, means the movement at C point is RA into A, which is clockwise, means positive. So movement at C, it is RA into A, where RA is how much? WB by L, that we have calculated already. So WB by L into A, so movement at C point is WAB by L. So here we have calculated the movement at A point, then movement at C point. So now we have the next point, that is B. Again take the section at B point and then focus on right, and then focus on left. So on left we have two forces, that is RA and W. So we need to take the moment of both forces. Okay. So first RA into perpendicular distance. Now perpendicular distance from B point, because we are taking movement at B point. So perpendicular distance is L. So movement of RA about B is RA into L. That is RA into L. But that movement is created clockwise. Okay, clockwise movement is there. So RA into L is positive. Then movement of this W. Okay, so movement of this W is again force into perpendicular distance, and the perpendicular distance of that W from B support or the B point is small b. So movement of the W is W into B at B point, and that movement is anti-clockwise. It's anti-clockwise because the direction of that force is downward. So anti-clockwise movement is there. So due to that anti-clockwise, we will consider it is negative. Okay. So movement at B point is so movement at B point is RA into W, that is positive, and W into B is negative. And we have calculated the value of RA, where RA is what? WB by L. So WB by L into L and minus W into B. So here the LL will get cancelled, remaining term is WB and it is minus WB. So WB will get cancelled, so it is 0. So here we have calculated the movement at A point, C point and B point. So just draw the bending moment diagram. Again, for the calculation or for drawing the bending moment diagram, we consider the base point. Okay, and again same rule, if any bending moment value positive, so it is upward or up to the baseline, negative below to the baseline. So bending moment at A point 0, so it will start from A point from 0. Bending moment at C is WA by L, that is positive, so it is upward, that is WAB by L, and the bending moment at B point is 0, so it comes to the 0. So bending moment at C point is WA by L. So this is a simple shear force and bending moment diagram for simply supported beam carrying eccentric point load. So here for the standard case, you can directly consider the support reactions. You should remember that support reactions and the bending moment value for the calculations. Okay, or in interview also they will ask the direct value for the bending moment and the support reactions for the eccentric point load. So the support reaction at A point is WB by L, support reaction at B point WA by L. The maximum bending moment for the simply supported beam carrying eccentric point load is WAB by L. So just remember that formulas and the standard procedure to solve the shear force and bending moment calculations and draw the bending moment and shear force diagram. Thank you. The next case that we will discuss in the next video, because I want to split all the numericals or all the standard cases in the different part, because if we cover all the basic cases in one video, so maybe that video will go in long length. That's why we have split, or I am splitting that videos. Okay, so hope you are getting some knowledge from these videos, and that videos are really useful to you. So I request everyone, please subscribe my channel and please like this video, so uh, I will get motivated from your likes and subscriptions. Again, I'm planning to upload all the videos which are related to the structural subject. Means in future we will going to upload the videos on the RCC design, then steel structures design, pressure structures designs, and some analysis also, structural analysis also. Now here just we have started only for strength of material. Okay, so please like and subscribe my channel. Thank you.